Okay, also first section will be 5.1. And that deals with rational expressions. And remember, when you're talking about rational expressions, we're talking about fractional expressions. But nothing new for us. So the first problems on here, they want us to find all numbers in which the rational expression is not defined. So find all numbers in which the rational expression is not defined. Let's see, they got two of those that we're going to do. So they're giving me an expression, 5c squared minus 12 over 6c plus 29. So what we're talking about, finding the numbers in which the rational expression is not defined. They're wanting me to find any numbers that'll make it undefined. And remember, the only way for this to be undefined is if we have a 0 in our denominator. So what we do, remember, we're going to take the bottom of this fraction, set it equal to 0, and any answers we get are the numbers we will have that'll make it not defined, okay? So it's just getting you ready for doing the domain stuff. So what I would do, I would take the 6c plus 29, set that equal to 0. And then we're going to solve that. So y'all on this one, we're going to what? Subtract 29 from both sides. So I get a 6c equals negative 29. And then divide both sides by 6. So that cancels, and I get c equals a negative 29 over 6. So the answer blanks will say the rational expression is not defined for c equals blank. All you got to do is put this negative 29/6 in that answer blank and be done. Now, we'll say the difference between this section 5.1 and the earlier sections when we did the domains, they're now going to put quadratic type equations in that denominator. So instead of just getting one number now, we might get more than one, okay? So y'all watch this one. We got a y squared minus y minus 5 over y squared minus 11y plus 30. So notice, I got a y squared down here. Since I got an exponent 2 on the bottom as my highest exponent, that's telling me I need to find two numbers that'll make this not defined. So once again, we'll take this denominator, set it equal to 0. Now to solve this quadratic type equation, I'm going to factor it. But if you like doing the quadratic formula, you can solve those doing that method. But y'all, everything in today's lesson we'll be able to factor. So I'm going to draw my two sets of parentheses. I know there's a y squared. So I'm going to put a y in front of both of those parentheses. So y'all, if I was going to ask y'all a question, see if y'all remember when we were factoring, what two signs would we put in these parentheses?
Negative.
Two negatives.
Oh, two negatives. Good job. Good job. Anytime that last number is positive, like that 30 was positive, both signs will be negative like the middle. And then y'all, the trick to factoring is just finding me some factors of 30 that'll add to get that 11. So let's see, 30 is what? 1 times 30.
5 and 6.
Yeah, there you go, 5 and 6. And since they're both negative, it didn't matter which one we put where. You can have y minus 6, y minus 5, no difference, okay? All right, now to finish this out, I take both of my factors, set them equal to 0 to get those solutions. And you'll notice when the factors are both negative, the answers will actually both be positive on this. Whoops. That should be y equals 6. There we go. So we don't have a blank. The expression is undefined for y equals. You'll just put in your 5, 6 and be done. All right, so just remember that when you got an exponent 2 as your highest exponent, you get 2 answers. Over here, my C technically had an exponent 1, so I only got 1 answer. Now, for the next few problems, we're going to find the domain. So we're going to find the domain. And remember, when you're finding the domain of these fractions, it's going to be all real numbers except for whatever numbers we're kicking out. Okay, so we're going to find the domain of the function. Now, y'all, they want me to write my domain 2 different ways. They want me to use set builder notation. And set builder notations when I had the fancy looking parentheses and I put the X and then that vertical bar, which meant such that X is a real number and cannot equal whatever. And then they want us to use interval notation. And that's when I use the parentheses. And if I kick out a number, I use that union, okay? So we'll look at both of these. So let me do number 3 here. They're giving us f of x equals 5x minus 9 over x plus 5. And y'all remember that domain is the same process as finding these numbers that made it undefined. I got 1x down here with an exponent of 1 by it. So I'm just going to set this equal to 0, and I'm going to get one number that I got to exclude from my domain. All right, so we got x plus 5 equals 0. Solve that, we'll subtract our 5. So that'll get x equals a negative 5. So let me do set builder notation first. Now, usually on set builder, they'll have most of the answer filled in, and they'll give you an A, B, C choice. And you just pick the one that has the not equals and then put your numbers in. Remember, don't pick the one that got equals, or don't pick the one that says it's all real numbers. I hear you. Oh, did someone have a question? I thought I heard something.
No, I forgot to have my talk on.
Oh, okay, you're good. All right, y'all. So my set builder notation would be x such that x is a real number. And x cannot equal negative 5. Now our interval notation, remember, I use parentheses and I start at negative infinity. And I'm cruising along all them x's until I hit negative 5. Now, since negative 5 made it undefined, we're going to union around that negative 5 using our union here. And remember, the curvy parentheses, when they're around numbers, the curvy parentheses mean that it does not include that number, okay? And then, y'all, from negative infinity, we're going to go, from negative 5, we're going to go towards positive infinity, and be done. So all your domains will start at negative infinity and they'll end at positive infinity. The only difference is what numbers you're going to exclude when you're done, okay? Yeah, remember earlier, most of the time they wanted us using set builder notation. So are y'all good on that? All right, let's try this. And g of x equals 3 over.
Well, I'm sorry, I did have a question on that.
Okay, I hear you.
So if it's such that x cannot equal -5, because it's been a while since we've done this, why is -5 in there again?
Why is it -5?
Well, I mean, why is -5 in the interval notation?
Oh, because when you got a number you're going to kick out of your domain, you use the curvy parentheses and you union around that number. So what this domain down here in interval is telling me, I'm going now. Infinity always has a curve, remember, because it don't have a stopping point. It just keeps going and going and going. So you're coming in from negative infinity until you go and hit that -5. Now, -5's got a curvy parentheses, which means it's excluded from that domain.
Okay.
And then I pick up on the other side of that -5, and I'm off to the races until I go to infinity.
So the bracket means that if we had a bracket, it means it is included.
It is included, and we used the brackets when we were doing the square root ones, and we said, remember that the square root had to be greater than or equal to 0.
Okay.
So since you had that little bit of equals on that, that caused us to use those brackets.
Okay.
All right, now this one, y'all, was 3 over 2x minus x squared. So y'all, once again, I'm going to take that bottom, set it equal to 0. Now, I'm going to factor this in a way. We haven't done much of this kind of factoring, but are y'all familiar with factoring out a greatest common factor?
Yes.
Yes, because if you notice both terms of these, there is something they got in common that I can actually factor out. And that'll be in the x, right? So both of these have at least one x. So we're going to factor out the x as a greatest common factor. Now, if you factor out the x, you take both of these terms, factor by the x, and put that in parentheses. So the 2x divided by the x, those x's would cancel. All that's left is our 2. And then if you remember when you got variables, x squared divided by x, remember this x really has a 1 by it for the exponent. So I'm just going to subtract exponents. So x squared divided by x, 2 minus 1 leaves me 1x. And if you notice what's in the parentheses, they no longer have anything in common. And usually that's the first thing I look for when I'm factoring, if it has a GCF or not, okay? So now we got 2 factors. I'm going to set them both equal to 0. And y'all remember, I got an x squared down here, so that 2 is telling me that we will exclude 2 numbers on this. All right. Every time we've had a single variable like that x as a factor, it always equaled 0. Back when we was doing section 7.2 and 7.3 and so forth, single x's always have a 0 of 0. Now, y'all, the one on the right, we actually got to solve that. Now, there's 2 ways you can solve this. One way would take you 2 steps. The other way would take you just 1 step. And the 1-step method would be, this x is negative on the left side. How about I come in and add an x to both sides, and I get my 2 equal to my x. Now, the other way you could have done it, you could have subtracted 2 from both sides, but then you would have had to take care of that negative x by dividing both sides by -1. But you still would have got x equals 2 for that answer. All right, also set builder would be X such that X is a real number. And X is not equal to what I get. I got a 0 and a 2. Now, over here, one number, I had one union. Since I got two numbers, I'm going to have two unions on this. I'm going to start at negative infinity, cruising in from negative infinity. The first number I would hit would be that 0. So remember, you always got to go left to right on these. So we would exclude the 0 by unioning around that 0. Now from 0, I'm cruising along the x-axis until I hit 2. So we're excluding 2, so we're going to union around the 2. And y'all, at this point, no more numbers to exclude, so we head towards our positive infinity. And y'all, so like I said, the main difference from this and y squareds and x squareds at you, okay? All right, so let's do one more of those and then we'll get into our 8.5. So this one, 5 is a repeat. So I'm going to do number 6. Because it's got a square on the bottom. So this one is f of x equals x to the third minus x squared plus a x plus 1. All that over x squared plus 8x plus 7. Now, they're just trying to intimidate you with all that stuff on top. But remember, on these problems, we don't care what's up there. We only care about that bottom. Now, remember, this is 3 terms. So notice they don't have a GCF. So I'm going to factor this one into 2 parentheses, okay? So we know we got our 2 parentheses here. X squared will be an x and an x. All right, so give me 2 signs for this one.
Positive and positive.
Positive and positive. And then how about my factors of 7? That'll give me 8.
7 and 1.
7 and 1. And y'all, what's nice, 7's a prime number. So that's the only factors you can use on 7, right? All right, so let's get these signs changed. So both of these will subtract. So I get a -7 and a -1. Now, y'all, I'm going to tell you this question is picky on the intervals. They want me to use ascending order on these. So we're going to use ascending order. So we're going to start with the smallest number and then head towards the bigger number on our intervals, okay? So first in set builder notation, x such that x is a real number. And then let's see, x is a real number and x cannot equal. So remember, -7 is smaller than -1. So I would have to put my -7 first and then my -1. And I think the only reason they're doing that on this one is so that when you do the interval notation, you put these in the right order. So from negative infinity, we're going to go toward -7. We're going to union around -7 until we hit our -1. And union around that -1 till we hit positive infinity. So y'all, that is 5.1. Mainly a repeat of earlier math, okay? So what we want to do now is get into our 8.5, which is rational functions. Now, y'all, I won't do the first two. The first two are just doing domains and using interval notation only, just like we did in 5.1. What I want to do is start introducing y'all to some new terminology for this section. So the first term is what we call a vertical asymptote. ASYMP TOTE. So y'all, a vertical asymptote is like an imaginary dotted line. How about this? Imaginary vertical line. So imaginary vertical line that occurs where a function is undefined. So if this problem I did up here a while ago, since this was undefined at -7 and -1, if I had a graph over here and say here's -1 and over here was -7, it would be like imaginary vertical lines at that point and at this point. That means my graph cannot cross these lines. So say if I had a graph coming in on this side, as it approaches this vertical asymptote, it's going to try to turn down and head towards negative infinity. Because it cannot cross that line because remember, that's undefined. Now this side usually will come in from positive infinity and head down and then come across. But notice, neither side crosses this dotted line that we have here, okay? So they occur where my function was undefined. And then over here, I would probably have one, this side would probably come up. And then this side would come in from negative infinity and probably try to cruise over. We'll get into more of them later, but just remember, these are imaginary vertical lines that the graph cannot cross, okay? Now, they come in the form of an equation. X equals that number. So say -7 was my undefined point. My equation for the vertical asymptote would be X equals -7. Because at -7, I would have that vertical line, okay? Remember, X's are vertical lines and the Y's were the horizontal lines. Now, it is possible for a vertical asymptote to be canceled out. And when an asymptote is canceled out, it makes a hole in the graph. So a vertical asymptote can be canceled by the same factor in the numerator. So say when I was factoring this, when I factored it, I had an x plus 7 on the bottom, x plus 1. If I'd have factored the top and I'd have ended up with either of those factors, x plus 7 or x plus 1, that would have canceled out that vertical asymptote and just created a hole in the graph, okay? So a hole in the graph is just a graph going, and then say it was undefined, and then it kept going. It creates a hole instead of a vertical asymptote, okay? So remember, when it gets canceled by the same factor in the numerator, this results in a hole in the graph. See, it cancels that asymptote, but it's still undefined at that point, so that's what creates that hole. Now, y'all on your calculators, you're not going to see that hole, okay? It's too small to see on those calculators. They're not enough pixels, I think they say. All right, y'all, that's a vertical asymptote. How about a horizontal asymptote? Now, horizontal asymptotes have nothing to do with being undefined or not. A horizontal asymptote is an imaginary horizontal line that the graph tries to approach as the x values head forwards, negative infinity and positive infinity. So y'all, this graph I did up here, this right side right here, if it kept coming and coming and coming, and I kept getting closer to the x-axis, so say my horizontal asymptote was y equals 0, this graph would try to get closer and closer to the 0, but it never reaches it. It just tries to get closer and closer as this graph heads out towards those negative and positive infinities. Now, I'm going to pull my camera down a little bit. There's 3 cases that determine the horizontal asymptotes. Now, let me write this also. These come in the form of y equals some number. Now, to determine my horizontal asymptotes, there's 3 conditions, and I'm going to compare the degree of the top with the degree of the bottom. Remember, the degree is the highest exponent. So if the degree of the top is greater than the degree of the bottom, so if I got bigger exponents on top, smaller exponents on bottom, this thing heads towards infinity, and there is no horizontal asymptote. Because y'all, if you got bigger exponents on top, the top is going to keep growing a lot faster than the bottom, okay? Second case, if the degree of the top is less than the degree of the bottom, so what happens if the top has smaller exponents than the bottom? Then the bottom is going to be growing a lot faster than the top. When that happens, my horizontal asymptote is y equals 0. Okay, the bigger that bottom gets, it's growing a lot quicker. You get fractions that are bigger in the bottom, which are essentially trying to head towards zero, okay? Never gets to zero, but they head toward that direction. Go to third case. If the degree of the top equals the degree of the bottom. All right, if the degree of the top equals the degree of the bottom, then my asymptote will be y equals a over b, where a is the lead coefficient on the top, and b is the lead coefficient on the bottom. So if I had something like 2x squared on top, 3x squared on bottom, the lead coefficients would be 2 and 3, so I would have y equals 2/3. Okay, so I'm just looking at the number in front of the variable that gives me my degree, okay? All right, y'all, so this homework problem will start out with problems that want me to find all the asymptotes and then picking a graph for them. Now, I usually just graph these on my calculator, but some of these are easy to tell because of the asymptotes we're finding, okay? So let me get us a new page and we'll start playing with these examples. All right, so for these first two problems, starting at number 3, they want me to list all asymptotes. And then graph the function. Now, there's a third asymptote that they will ask you about in the homework. It's called an oblique asymptote. Put no oblique asymptote when you see that one, okay? Because we're not going to cover them in this class. But MathLab still includes them in the problems, okay? So first it'll start out with the vertical asymptotes. So let's get our function. We got r of x equals 8 over x squared minus 25. So I'm going to start out with my vertical asymptotes, and I'm just going to call them VA. Remember, to find my vertical asymptotes, I'm going to take the bottom of this fraction and set it equal to 0. So you can factor this one if you want, but I'm going to solve it by doing the square roots because I got an x squared term and a number. So usually the quickest way is to go through on this one, add 25 to both sides, get an x squared equals 25, and then take the square root to get them two values. So that I get an x equals a plus or minus 5, which means my vertical asymptotes are going to be x equals 5, comma, negative 5. Now, what's nice on those, they will let you use commas and use it as one equation, okay? So y'all, that's your vertical asymptote. Then we'll find our horizontal asymptote. So here's the question for the horizontal asymptote. On my fraction, is my degree equal, higher on the top or higher in the bottom?
On the bottom.
At the bottom.
There you go. So the degree on the top is smaller than the degree on the bottom. Good job. So what did we say when the bottom was bigger than the top? My horizontal asymptote will be y equals
Y equals 0.
y equals 0. There you go. Well, those aren't bad. You just look at the degrees and you got 3 choices, okay? Now I'm going to show you the picture of the graphs they would use on this. So let me zoom that in just a little for y'all. Whoop, wrong zoom. All right, so remember, we had vertical asymptotes at -5 and 5. Well, that one's got a -5 and 5. This one's only got one at -5. This one's only got one at -5. And then let's see, this one has one at -5 and 5. So I know my possibilities are between A and D. So then my horizontal, notice when this one's going to head towards 0, that one's going to head towards 0. So when I got 2 that are close together, I'm going to graph them to see if my U should be up or whether that U part should be down, okay? So let me take us to the calculator. I'm going to have to shrink this back down. And then redo it. Now, let me tell y'all something. When you graph these in the calculator, you got to put parentheses around anything that has more than one thing. The top only had an 8. I don't need parentheses. But in that bottom, since I got 2 terms, I got to use parentheses if you're using the old calculator. Now, I'll show you another way you can do that to make it look exactly like a fraction. So let me go to my calculator. So to graph this, I'm going to go to y equals, and I'll do it the old method first. I'll do 8 divided by parentheses, x squared minus 25. So x squared minus 25. Put that in parentheses, and then we'll hit graph. So look at it. It's the one where the U was shaped upside down. Now I'm going to show you the second way you can put in fractions. Remember one time I taught y'all that if you hit the green alpha button and the y equals, it brings up ND, which is numerator denominator for fractions. So if you do it this way, you can put the 8 on top and then arrow down and put in your x squared minus 25. If you use the alpha, y equals, you don't have to put it in parentheses, okay? Because it knows what the top and bottoms are. But like I said, if you use the divide and put it in that method, then the x squared minus 25 has to be in parentheses, okay? All right, so it's the one upside down. So on that picture, I would have picked that last one where my graph was upside down. All right, y'all, question on that. All righty, let me see. So let's try some problems where they want us to. So you'll have 2 to graph doing that, okay? So now we're going to find the vertical asymptotes of the function. And these start out about number 5. So all they want is vertical asymptotes, okay? So here we go. We got f of x equals 1 divided by x minus 1 squared. So notice, all I got on top is a 1. So when I play with this, there's no way the 1 is going to have a factor that cancels my bottom. So I'm going to set my bottom. Remember, I'm looking for a vertical asymptote. So I'm going to set the bottom equal to 0. But y'all, x minus 1 squared means x minus 1 times x minus 1. So I'll write that twice. Now, since I got identical factors, all I got to do is solve one of those. Okay. So this is a case where you'll get one vertical asymptote, although you got a exponent of 2 down here. And it's all because they're repeats. Okay. All right, y'all. So you would solve that by adding 1. And your vertical asymptote would be x equals 1. Now remember, on that, you got to put it in just like that, like an equation, okay? All right, y'all, let me see if y'all got questions. All right, so y'all are good. So the next one, we got f of x equals x minus 9 over x squared plus 8x. Now, you see I do have an x minus 9 factor on top. When I factor this bottom, if I get an x minus 9 factor, I'm going to cancel it out because remember, that's how you would cancel out any of these vertical asymptotes, okay? So let's factor our bottom and see what happens. All right, y'all, I got an x squared plus 8x. The way we're going to factor this is doing a GCF again. Because both of these terms have an x in them. So factor out that x. And then divide both terms by x and put that into parentheses. So x squared divided by x will leave you 1x. 8x divided by x leaves you 8. So single variable again automatically equals 0. And then we'll take the x plus 8 and solve it. So let's see on that one. I'm just going to subtract 8. And again, x is a negative 8. So on that one, they actually got A, B, C, D, and they wrote it twice. They wrote the x equals 0, and then they did a comma, x equals negative 8. All right, so notice how I'm always looking at the top, though, because once I got it factored down here, I'm checking to see if anything cancels on them, okay? Oh, let's see. What was I doing there? Okay, those were similar. So I went down to 9 next. 7 and 8 were similar to stuff we've already factored. So I'm trying to get stuff that we haven't factored yet. All right, y'all, the top, x squared plus 3x minus 28 all over the bottom, x squared minus 2x minus 24. So I know I'm going to play with the bottom for my vertical asymptotes. So let's set that bottom equal to 0. But y'all, I'll tell you the truth, we're probably going to have to factor that top also. Since it's not factored for us, we're going to have to factor the top to see what factors it has to see if anything will cancel. All right, y'all got an x squared, so an x and an x. So let me ask you, what signs you putting on this? So I'll give you. Well, you're halfway right.
Negative, positive, I believe.
Negative and a positive. Remember, the last one's negative. You got unlike signs no matter what. And then I'm going to find factors of 24 that'll subtract and give me 2. Because remember, when it's negative, your factors subtract. And when I get my 2 numbers, the larger one will be the same sign as the middle. So what factors multiply to get 24, but they'll subtract and get me a 2?
Is it
6 and 4.
6 and 4. All right, remember, the larger one's going to be negative, so our 6 is negative, and our 4 will be positive. All right, y'all, then the rest, we're just going to set them equal to 0 and see what we get. So we're going to get x equals -4. And x is going to equal +6. So what we got to look for real quick is what or not. So if we're going to have to factor the top, we know we got unlike signs. But here's the question. Do we have factors of 28 that'll subtract and give me 3?
Is it 7 and 4?
So 7 and 4. So guess what? We might have to go further, right? Because down here, I got a -4. So we're going to have to see what we get for signs on that top. So you got an x and an x. Negative again has unlike signs. The middle's positive. So guess what? Since the middle's positive, the 7 will be positive, and the 4 will be negative. But y'all look at that. That factored into an x -4. Our bottom factored into an x +4. So neither asymptote is going to cancel out. So we take both answers. But y'all, that's sort of how you got to check real quick. Just see if these things factor. Now, if that would have been an x +4, I'd have canceled that out with that one, and we'd have only had one asymptote. This one would have turned into a hole in the graph. All right, so let me let y'all catch up real quick, and then I'll turn that over. All right, y'all, so moving on now. So I'm going to do one like 10. I've got g of x equals x to the 3rd over 2x to the 3rd minus x squared minus 36x. Now, that bottom has the x to the 3rd in it. That means I'm looking for possibility of 3 vertical asymptotes on that. So I'm going to start out by setting my 2x third minus my x squared minus my 36x equal to 0. So y'all, before I try to factor it into parentheses, I need to do one thing to this problem before I do that.
Is it combined term?
Oh yeah, I heard it. We're going to factor out that x. Good job. And on this problem, if y'all start with an x3, you're probably going to factor out an x, okay? Now, if you factor out an x, all of them are going to go down by 1x. So you're going to have a 2x squared in here minus the x minus 36 all equal to 0. Now we know this x is going to equal 0 because remember, anytime I had a GCF of an x, it always equals 0. So what we got to do here is go further on this stuff in the parentheses and try to factor it. Now I'm going to show you how I factor these. So let me go to the side here. These are trickier to factor than when you just got an x squared in the front. And I'm going to show you a method that I do where it's not trial and error type stuff. So I've got a 2x squared minus x minus 36. All right, y'all, let me sign one in real quick. All righty. So to factor this, I'm still going to do my signs the same. I'm going to have unlike signs because of that negative 36. And my larger number will still have the sign as the middle number, which is negative. But what you got to do on these problems is multiply the first number times the last. And I don't even care about that sign. I'm just multiplying the numbers. 2 times 36 is 72. Now remember, that last sign's negative. So you want to find me, so we treat 72 like the last number now. So what I need is factors of 72 that'll subtract and give me a 1. So find factors of 72 that subtract to get a 1. So y'all, what to multiply to get me a 72? But when you subtract them two numbers, you get a 1.
9 and 8.
9 and 8. Now, which one would you make negative and which one would you make positive?
Would the 9 be negative and the 8 be positive?
There you go. Now, since I'm doing this method, I'm not going to put a plus because we know that 8's positive. But your next step, once you got these two factors, remember how I borrowed that 2 to multiply by the 36? Now, we have to divide both of these factors by the 2. So I'll take that negative 9, divide by 2. I'll take that 8, divide by 2. Y'all, can you reduce either one of them fractions?
The 8/2?
The 8/2. That 8/2 will reduce to a 4. Now, remember, these would be the factored numbers. To get the actual solutions, well, what do y'all remember about the factors and the solutions? Remember, the solutions are always opposite in sign than the factors. So to get the solutions, change the sign. Of both fractions. So over here, I would set this x equal to 0. My next x, since that's a negative 9/2, will be a positive 9/2. My third answer, since this was a factor of 4, that makes this answer a negative 4. So remember, this became a positive 9/2, and this one became a negative 4. Also, if you ought to use the quadratic formula for this part, quadratic formula would give you these two answers, 9/2 and negative 4s, okay? Okay, so I got 3 things factored here, but y'all look at the top. You got an x and an x and an x up here, right? So my question is, do these x's cancel with any of these factors? Oh, I hope one of y'all saying yes, right?
Okay, we'll cancel the x equals 0.
It'll cancel that x equals 0. So one of these factors will cancel out that factor. Since that factor got canceled out, that asymptote got canceled out, and our only two asymptotes would be the 9/2 and the x equals -4. I think 10's the only one where you had anything cancel. But just remember, if you get a single x and you got single x's up there, no matter what the exponent, it's going to cancel that single x, okay? Y'all notice this lesson today is nothing but a lot of factoring, okay? Okay, now it changes over at number 11. It changes over, and they want us to determine. We're going to determine the horizontal asymptotes. So it's got 3 doing this, okay? So number 11 is a f of x equals 2x squared plus 3 over 3x squared minus 4. So y'all, the degree of the top, is it greater, less than, or equal to the degree of the bottom?
It's equal.
So the top degree equals the bottom degree. So we said when that happens, my horizontal asymptote is y equals a over b. So y'all remember what I said, the a equaled and the b equaled. A is the lead coefficient on top. So what's your lead coefficient on top?
2.
Yeah.
Right, because remember, I'm just looking at these numbers right in the front, ain't we? And then the lead coefficient on bottom would be the 3. Now remember, if I don't have a number in front of that variable, you're going to treat it like a 1 on those, okay? But yeah, you look at where you got your degree, those numbers in front are your coefficients, and then you'll be done. 12 f of x equals x squared minus 5 over 3x to the 4th plus 4. So degree top greater, less than, equal.
Greater.
Less.
Okay, yeah, because see, my top's only got a degree 2. My bottom's got a degree 4. So if I'm talking about my top degree would be less than the bottom. So when the top was less than the bottom, what did we say about our asymptote?
There's not one.
Oh, go to the other one. Remember, for me not to have one, my top would be bigger than my bottom. Because remember, my top would just keep growing, growing, and growing versus that bottom. But on this one, your bottom's going to be growing a lot faster than the top. So when that happened, what did we say?
Y equals 0.
Y equals 0. All right, let me see what they did here. Woo, they got a big one here. F of x equals x to the 3rd minus 2x squared plus a x minus a 5, all of that over x squared minus 12. So where's that degree greater?
On top.
So it's greater on top. So your top degree is greater than your bottom degree. So what's that mean? When the top is bigger than the bottom.
No horizontal asymptote.
No horizontal asymptote. Good job. And they'll actually have like a choice B and you put no horizontal. I mean, you'll just click that, okay? All right, y'all. So what I wanted to do next, that's 8.5. Okay, so it focuses more on asymptotes in that section. So what I wanted to do with y'all was a little bit of support from 5.1. Just to work with y'all on some of this factoring, okay? So these won't take long. All of these want me to factor. So I'm going to start out with a 20r squared plus 5r. Y'all, what can you do to factor that?
Do the greatest common factor, which is r.
Uh-huh. Oh, you can even give me more. What else? There you go. So see, both of them do have a 5 and an r, so we're going to factor out that whole thing, the 5r. And then divide the 20 by 5 gives you 4. R squared divided by r leaves an r. So y'all, what would you put here? Because you got a 5r and you're dividing out that 5r.
A 1.
A 1. All right, y'all, that's done. How about this one? T to the 5th plus 4t to the 4th. What can I factor out of that?
Could it be t to the 4th?
T to the 4th. There you go. So good job. When you got variables, the GCF is always the smaller exponent of the two, okay? All right, so let's factor out that t to the 4th. Do you want to put you want to tell me what's going in them parentheses?
T and plus 4.
There you go. All righty. R squared plus 15r plus 56. So then they start getting into the trinomials. All right, r squared is an r and an r. What's your two signs?
Positive.
All right, and give me factors of 56. That
8
equals
and
15.
7. 8 and 7.
8 and 7. Or you could do 7 and 8. Remember, when they got like signs, it don't matter what order you go in. All right, y'all. 4 was a c squared minus 10c plus 16. Another trinomial, so we know that's going to factor into parentheses. I got a c and a c. All right, give me my two signs.
Would it be negative, positive? Or negative, negative?
Negative, negative. There you go. Remember, positive, like signs. All right, factors of 16, that'll give you 10. See, the trick on this is just getting them numbers, right? So what multiplies to get you 16, but adds to equal 10?
It's
8 and 2.
8 and 2. There you go. All righty, w squared minus 80 minus 2w. All right, y'all. So I'm not going to factor this one yet because I got to do something first. What do we got to do?
Put it in descending order.
Put it in descending order. Good job. I'm just going to rearrange it real quick. So we got a w squared minus the 2w minus 80. Now we can throw it in parentheses, w. What two signs would y'all put on that?
Negative? No, positive, my bad.
So I got a pause. Well, say both of them. How about that?
Yeah.
So the last one's negative. So we got unlike signs. Factors of 80 that'll subtract and get a 2.
10 and 8.
10 and 8.
So now let me ask y'all this. Who's getting what sign?
10 is getting a negative.
10 is getting negative and the 8 is getting positive. Good job. So that when you added that, that negative 10 and 8 equal negative 2, okay? So y'all, that's mainly what our support's doing and just having y'all factor a little bit. So let's try this one. 2y squared minus a 12y plus 18. So look at all three of them numbers and let's think about the first thing we would probably do to that.
Greatest common factor.
Greatest common factor. Good job. All three of them will divide by the 2. So if you always factor out them greatest common factors, what's left is a lot easier to try to put into its 2 parentheses, okay? So y'all divide everybody by 2, so that'll give you 1y squared minus a 6y plus a 9. So now we factor this inside the parentheses. So our 2 got to come down still. So don't lose that 2, okay? Because you got to have it in your final answer. Y squared is a y and a y. All right, how about these two signs? So y'all remember that last one?
Negative and negative.
Negative, negative. Now, how about factors of 9 that add to get me that 6?
3 and 3.
3 and 3. Now, do y'all see how you got these repeating factors? You can write it long ways like this, or you can come in and do 2 times y minus 3 squared. If you want to shorthand it, you can do this, or it'll take it either way, okay? Y'all, there's only one more to do, so let's see what we got here. See, factoring ain't bad that y'all been doing it enough times now. Y'all are getting pretty quick on these. So how about a squared plus 4a minus 32? So do y'all want to factor that, and I'll give y'all a few minutes and see what y'all get? And then we'll see if y'all are right or wrong. All right, so we know we got A and A. So who's done and what signs did you put?
So I'll give a stab at it. It's a plus 4, a minus 8.
So you got an A plus 4 and an A minus 8. Oh, I'm looking at you. Look at that. Negative 8 and 4. When you add those, you're going to get a negative 4.
Oh yeah.
So change them signs. And we'll have the A plus 8 and then the A minus 4. All right, y'all, real quick. Let me show y'all something on this. 8.5 support. It only has 3 problems, but I don't know if y'all are familiar with this terminology. They want us to simplify by removing factors of 1. Basically, it was doing, when I was doing the asymptotes, remember, and I said if I got any factors that cancel with any factors on the bottom, basically, when you're canceling them out, you're turning that into a 1. So that's what they're talking about here. So watch this. 6y minus 18 over 6y plus 18. So we're going to factor the top and factor the bottom, and then if anything matches, cancel that out. So I ask y'all this. You got a 6y minus 18. What can you do to the top of that?
Divided both by 2.
Oh, you can even go bigger than that.
4.
A little bit more.
6.
Mhm. See, they got a greatest common factor of 6, right? So to officially be able to do that, I'm going to factor out the 6 on top. If you factor out a 6, 6 divided by 6 is 1y minus 18 divided by 6 will leave you a 3. So we just factored out the GCF of a 6 on top. Well, guess what? The bottom has a GCF of a 6. So you factor out that 6, 6y divided by 6 leaves you y, plus 18 divided by 6 leaves you 3. So y'all do see now I got a factor on top that matches the factor on the bottom. So these factors would cancel out, and your final answer would be the y minus 3 over the y plus 3. And y'all, that's what they meant by factoring out the factors of 1, okay? 6 divided by 6 is 1, and that's why they say that. How about this? P squared minus 49 over P squared minus 14P plus 49. I'm going to factor the top and bottom. Now, y'all, the reason I went straight to parentheses on top, because there's no common factor on these two terms, okay? This is what we call the difference of perfect squares. P times P, and then there's a number that equals 49 times itself. So what you do, you put a P and a P. The last sign's negative, so one of these is positive, one is negative. So since there's not a P in the middle, it's like the middle number is a 0. So what factors of 49 will subtract and give me a 0?
7 and 7.
7 and 7. And see, that's why we call this the difference of perfect squares, P times P, and then the 7 times 7, okay? All right, let's play for bottom. We got a P and a P. Last sign's positive, so both of these will be negative like the middle. And this one wants to know what factors of 49 add to get 14.
7 and 7.
So y'all notice that. I got a P minus 7 on top. I got 2 P minus 7s on the bottom, but I can only cancel one of these out. So I'm just going to take that P minus 7 on top, cancel out with that P minus 7 on the bottom. So our final answer will be the P plus 7 over a P minus 7. All right, so we're going to do one more, and then that's it on this lesson today. X squared minus 5x plus 6 over x squared plus 3x minus 18. So two trinomials, we're going to straight go into our parentheses. All right, top, I'm positive, so both will be negative. So I'll have an x minus, x minus. I need factors of 6 that add to get me a 5.
2 and 3.
6 and 1.
Oh, 6 and 1 subtract to get
My
5.
bad. My bad.
Uh-huh. So remember that last sign is going to tell you whether to add or subtract on those. All right, this is a negative at the back, so one's positive, one's negative. Give me factors of 18 that subtract to get 3.
3 and
6 and
6.
3.
So my middle's positive, so my larger number 6 will be positive, and my 3 will be negative. Actually, if you get the signs backward on this, it wouldn't even cancel. But since we got an x minus 3 cancels with an x minus 3, we end up with an x minus 2 over x plus 6. So y'all, that is 5.1 was mainly working on the factoring. 8.5 support also was working on factoring, but they were doing it with the actual fractions, so that when you did those vertical asymptotes, if you had anything matching, you would be able to cancel them, okay? All right, y'all remember next Monday, we're going to finish our last section, 8.6. It's not too bad. It's only like 6 or 7 problems. So it'll have a little bit more factoring in those sections. And then we're going to start reviewing for 3. You know, after that, it's all on the home stretch, right? Test 4 material. And y'all gonna be done with this, okay? Now, I wanted to tell y'all a few things. Any of y'all nursing?
Yes.
Okay. Now this goes to everybody, but especially nurses, because y'all's classes are limited. Especially if you're trying to get microbiology, A&P, and some of them classes, y'all are what we call returning students. And registration opens up Tuesday morning, April the 4th. So if you want to get a good schedule and get the classes you want, y'all need to get up April 4th and start signing up for your classes, okay? So go into your portal, go to the student section and click on that box that says add and drop classes. It opens up summer 1, summer 2, extended summer registration, and fall registration. Y'all, if you wait too long, those classes are going to go quick, all right?
So
Thank
what time can
you.
you get on the portal?
Do it now?
What time will the portal open for? Because I'm up at 5 o'clock every morning.
Yeah, you might check it. It might pop open after midnight. I'm not sure.
Okay.
I haven't seen the actual time, but usually that stuff, once it clicks onto that day, it's ready to go. Yeah, because those classes are hard to get, any science classes, because what it is, they offer like 2 or 3 on campus, and then everything else is online. And it's hard taking them science classes online with them labs. So y'all just be prepared, all right? Get up and try to get what you want for your schedules. Add them and be done. All right, y'all, as far as the math, let me stop this share. Any questions over anything? So let me
Yes,
stop.